Dan Abramov is back for real this time. Not at Meta, to be clear, but he's back and giving one of his best talks to date. I had high hopes because he's been stumbling around figuring out the right way to communicate server components for people like me to go copy, remix, and share with y'all. And I think he really hit the nail on the head with this one. This is kind of the next version of his Tale of Two Reacts talk, but it does a much better job showcasing how React has changed because in reality, there is still just one React. There's just two computers. What the hell do I mean by two computers? Great question. Without further ado, let's watch React for Two compilers, give some insights, talk about all the things I chatted with Dan about when at ReactConf, because we talked a lot, and there were some really interesting insights I got from chatting with Dan.
Okay, hi. Excited to be here. My name is Dan Abramov. I work as a software engineer at Blue Sky. We're building composable, open source social media, so check it out if you're into that kind of.
By the way, cool thing Dan doesn't talk about here, but is mentioned in other times throughout the conference. Dan's work on Blue Sky has been very nice for the whole ecosystem because it's put one of the main React team members, somebody who really helps drive React's direction, deep in app dev land. He has now gotten a lot of experience in all the things we app devs deal with every day, from MobX being weird to painful bundler issues to the default templates in the React native ecosystem being kind of crappy to ESLint rules not behaving how they should. Like all the things we experience actually building with React are top of mind for Dan now. And that has been awesome because he had a real project with a bunch of contributors that he changed a ton of things about and got to learn these migration stories, see these benefits, see the things that sucked, and just better understand our pain as React application devs. He also, through this process, managed to gut all the MobX code from Blue Sky, which is an open source React Native app, by the way. Check it out if you haven't. It's actually a really cool example app. He managed to gut all the MobX stuff, simplify it a whole bunch, and then add React compiler and make the app significantly faster, which I think is really cool that not only has Meta succeeded in adopting compiler, he has on a real app that has nothing to do with Meta at all. Cool stuff. Just wanted to go on that quick tangent because I think the Blue Sky thing here isn't something to write off. I think it's given him a lot more context on how application developers experience these things today.
But my talk is not about Blue Sky. My talk is about React, and it's called React for Two computers. The first thing you should know about this talk is that this is a talk.
And since it's a talk, there will be water drank.
Sure. It wasn't supposed to be a talk, so I thought that this would be a blog post.
Also, a fair point. If you've already seen my Tale of Two Reacts video where I talk about his blog post, his writing is incredible. And traditionally, his writing is more focused and his talks are a little more open and looser in terms of their process and where they start and end. This is one of his most buttoned down talks, probably his most ever buttoned down talk, where it kind of feels like a blog post in terms of how he goes through things. But it is a talk. It is a very, very pointed one. I almost think this might have been a good opening, but the opening wasn't just about server components. The opening was barely about server components. So I get it. I need to stop pausing. It's we're probably 5+ minutes into the video. We haven't even started the talk yet. Sorry. That's what you're watching for, though, right? You'd watch the talk if you wanted to just watch that.
And I tried to write this blog post maybe 13 times. I have a bunch of drafts that I never published. And I just couldn't quite figure out how to do it. And I realized later that it's just because this is just a different format. And actually it makes more sense as a talk. So how is a talk different from a blog post? Well, a talk is a performance. So I'm standing here, I'm in front of you, I'm speaking things, doing things. I might mess it up. I'm a little bit nervous. But it's some kind of live action. And there are things you can do in a performance that are hard to do in writing.
This is also a nice reminder that I should probably write more because I don't love performing all the time. I do my best. Seems like you guys like watching, but it's a nice opening here to point out that sometimes a performance is the right way to communicate an idea, and the ideas in server components don't seem to be very easy to explain just via writing. Sometimes you need to hear and experience them.
Talk is not just a performance. A talk is also a story. So I wrote some kind of a story, and I came here with this story, and so this is the thing that I'm presenting. So you could say that in a way, this talk is kind of like a collaboration between two people.
He talked about this with me a bunch too. A specific goal he had for this talk was for it to be more conversational, more remixable, as he put it, and to intentionally leave gaps for somebody like me to come in and give their feedback and thoughts and maybe adjust the talk and do it their own way. Effectively, he gave me permission to react to it, which is what we're sitting here doing. And I love that. But also, it's kind of the goal of the channel. I never wanted to just be a talking head spouting whatever the heck I think is cool or not. I wanted it to be a back and forth and more conversational. And it's really cool that he is presenting this in a way that I can riff off it and have something that feels like the back and forth that we had after the talk, actually talking about these things.
So there's me, who's presenting right now here at the stage, given this performance. But there's also the past me who has written this talk and the story for it. And me and the past me, we're never in the same room. Like we're kind of separated by time and space. Like the past me is somewhere in London trying to figure out like what to write about. And the
past Dan was also in his hotel room the night before until like 1 a.m. working with Michael Chan to get these talk really buttoned down. So shout out Chantastic, by the way. Makes so many of these things happen behind the scenes and never gets the credit for it. Absolute legend. But yeah, past Dan put a lot of work into this one.
Present me is here. But there is a kind of communication between the past me and the present me. So the past me has written a certain script for this talk, and the present...
If you get server components deeply enough, you might already see the very clever joke here. This is very, very clever.
Me is using the script to kind of finish the performance, and then the talk is not ready until both of the stages are done.
He's so goddamn clever. He's so goddamn clever.
Sure. So this kind of relationship between past me and me, it's kind of similar to, there are like other kind of patterns of human relationships that follow the same structure. So one similar relationship is between the scriptwriter and the cast of actors.
Or the blog post and me reading it live on a video. It's a lot of examples of this. Okay, that's a little different because I interpret it, but I got to lean into the joke, okay? Like if I'm doing a React video about React Conf and reacting to it, I got to make some reaction content jokes.
So, if like the scriptwriter is working on like a TV show or a movie, or like a playwright for theater, like they write a play, and then that is the first phase of the process. But then the play isn't really played until the actors actually embody, the story and like bring it to life and then connect to the audience. So it's kind of like a two-step process where the author and the actors communicate in one direction through text or some kind of a script. So this pattern exists in human relationships, but it also exists in computer relationships.
For anybody who missed the joke until now, hopefully you see it here. The server sends script to the client for the client to do things with.
If that is a concept. So the pattern I want to talk about today is like the relationship between the server and the client. And there are different kinds of servers and clients. People mean very different things by it. So I just mean server and client as not even necessarily machines, more like computer programs in kind of context of like traditional web development request-response model. So the client requests some page from the server, and then the server responds with something that the other computer should execute. So some kind of HTML and maybe some scripts within this HTML. And maybe if you think like of the word script a bit more metaphorically, like HTML is also kind of a script, right? Like it's like a programming language for what the computer should display. So the whole thing is kind of like a script.
HTML as a script is an important piece that I want to make sure you guys don't lose, because that's going to be coming back a lot.
And so I want to dig into this a little bit, into this.
Can we all take a second to admire the simplicity of his slides? Like he used Keynote, because almost everyone did. It probably should have been on my fake list of rules. But yeah, his slides are very basic because he did a very ballsy live code for this. And I have massive respect for him for that.
And so I've prepared a little example. As everyone knows, the naming of cats is a difficult matter. So,
as somebody who has a cat named after Lil Yachty, naming cats is hard. I lucked out because Lil Yachty ended up being one of the coolest people in music like 7 years later. But my cat that I got in 2016, I named after Lil Yachty. Naming cats is hard.
Sometimes you need an app for that. So,
good use of an app.
In case you need to name your cat, you just press. It already picks. It already picked the name for me. So I just press reveal. And I see, this is the name that is chosen for my cat. And the way this works is that there's an array, kind of hard-coded array of cat names, and I pick a random index from that array, and I take that cat name and display it in the document body.
note that there is zero React here. I think it was a very good choice to not use React for a lot of this talk. I think it really showcases how these things work on a technical level. So just wanted to call it out. There is no React in this code. He's manually setting the document body inner text to be the cat name value.
And so this is fine, but sometimes I don't really want to hard code, like let's say I don't want to hard code the list of cat names right here, because I want to have some kind of flexibility. So I want to be able to maybe fetch it from the database or read it from a file system, maybe ask ChatGPT. I don't know, like I want to have some kind of flexibility not to hard code the data that my application needs directly in my application. And so the way I would usually solve this is pretty traditionally, I would, I would have some kind of an API. So I'm going to do like await fetch. I've already prepared an API called cat names. And I'm going to get the JSON from that API. And I'm going to read the cat names from that JSON. And so let's see what happens. I'm going to refresh the page. Oh, I see there's an error. It says await is only valid in async functions. So yeah, I need to make this function asynchronous.
If I recall, that's the only mistake he makes the entire talk. I don't even know if that one was meant to be scripted or not.
Let's refresh again and press reveal, and it works. Yay! I didn't break anything. That's a milestone. So yeah, this works. Ship it. I can go now.
Yep, complete. Who needs anything better than this? This is totally fine. Okay, you'll see why in a bit. I'm sure all of you guys can sympathize with this example. You fetch something from a database or API endpoint, you get it into JSON, you get the values, and then you do something with that. But you might notice we returned all the cat names here. We don't need all of them. We're just selecting a random one. There's a lot of little things. And I'm excited for him to show how those little things get better over time.
I can go now. But there is a little bit of a problem that I actually changed the behavior quite a little bit here, because now if I load the page and let's say that my connection goes slow, so I'm going to throttle it, and then I press reveal, it's not instantaneous anymore. Like it takes some time to load because the data doesn't exist at the time the user interface is rendered. Like now I have to go get it from the API and wait for the response. And so maybe if I load the page and then my connection goes out, it will not appear at all. And in some cases, this is actually fine. In a lot of cases, this is fine because, for example, like if you click a link or you navigate to another tab, you kind of expect that, well, we're going to the server, like we're navigating, so we need to fetch some information, so you expect some kind of a delay. Or if you're mutating some data, so like if you're saving settings or submitting a post or liking a picture or whatever, like you kind of expect, well, it's normal for these kinds of things to take time.
This could be argued as a subtweet of things like HTMX and LiveView, LiveWire, all these attempts to move all the logic to the server, because there are certain things you just expect to work immediately on the client, like opening a menu or revealing the cat name. But there are some things that you don't, and that's reasonable. If the majority, even like the vast majority of your app is things that you expect the server to have to do some work, something like React probably doesn't benefit you at all. But the reason you bring in React is you want to do things on the client. And that's where I think this starts to get a little magical, is what if you can interweave and use the best of both where it makes sense for each.
But then we also want to have this kind of control over our user interfaces where we want to be able to say this particular interaction has to be synchronous. Like, I want the data to already be there with that screen. I don't want to wait for it to kind of come later.
And the things I've seen people do to fix that, I was just reading some code yesterday from a brand new code base from an influencer in tech. They're not a big tech influencer, but they're an influencer that happens to be an engineer. And despite this code base being made 2 to 3 months ago, it was a giant mess of chaotic dispatchers on Redux, where when you first load the page, it goes and fires off 15 API requests, all of which are leaking keys in the client bundle. And it's secure, secret keys that are supposed to be on your backend leaking to the client so they could go fetch these random things that the server should have provided, all to hopefully get the data into Redux in time that when you click the button, it might already be there. And it's utter chaos. And those things are so common that it's insane. And we've invented so many crazy solutions to the problem of, I want this button click to be sync, but the data I need is async. What do I do?
there with that screen. I don't want to wait for it to kind of come later. Like I want to be able to ensure low latency for specific interactions. So how do we fix this? Any ideas? It's kind of like not obvious how to approach this problem if you look from the client-centric perspective, because, well, this is all I got, right? I have this fetch call, have to await it. There's not much I can do there. So maybe one thing we can do is we can look at the server code. So this is my server. You can see there is an NPI endpoint that I created that reads from a file. This is my list of cat names.
I know there's going to be some web devs here that aren't as familiar with the server-side stuff, so I'll do a quick explanation here. The server function is a really basic web server. So when a user makes a request to the server, it has to determine what it sends back as the response. It checks the URL, which is the URL string here. And if the URL is /API/catnames, then it reads from this cats.txt file, it makes it into JSON, and then it returns that. If it isn't that, so if it's just /, then we return this HTML string instead. So this is pretty similar code to what you would see in most web servers. Usually it'd be some type of functional builder pattern or something, but it's a good simple example. The URL is the API, return JSON. If it's the root, return the HTML. Hopefully that makes this function a little more understandable, because is beautifully simple and elegant, but also not that far from reality.
And just returns the JSON. But if I keep scrolling down, there's something interesting here. So there is a script tag here that says, here's the client code for this page, which points to this code. And just to kind of make it more visually obvious what is really happening in our program and how our program is really structured, I'm just going to copy and paste this. So I'm going to put the code of this client code inline into the script. So that's not necessarily like the best way to write production code, and there are more kind of efficient ways to do this. But for illustrative purposes, I think it really helps kind of explain what's going on in the code.
I am genuinely really curious. So if you're watching this right now and you're trying to follow along and figure out server components, I want you to comment what timestamp it clicks for you, because I know this talk is going to make this click for a lot of people. So say in the comments, what timestamp in this video was the one where the server component mindset clicked, because I already see in chat, this is where it's starting to click for some of y'all. But it's going to get way cooler in a second, because what he just did here by moving the JavaScript in really does a good job of showcasing the magic here.
And let's just refresh to verify that, yeah, the code still works.
It does suck that you lose the syntax highlighting, but that's like one small detail as we learn a really cool pattern here.
So previously I was looking at the server code and the client code as kind of two separate programs that talk to each other. They kind of pass messages to each other or like request stuff from each other. But now I'm kind of looking at it from a different perspective. So I kind of look at it as a single program that spans two different devices, that spans two different computers. It's like a program that's evaluated kind of in two steps.
To be clear about the two steps, in case you're not following, which is understandable, this is a crazy concept that's being communicated here. The first computer is the server that generates HTML. Like the HTML, we think of it as a file if it's in our public folder in our code base, but most HTML is generated at request time. And the contents of that HTML can change based on information that the user has specific to them. It could be your auth information, it could be the route that you went to, it can be a lot of these different things. But effectively, your HTML is instructions for the user's device to follow. And those instructions can change depending on what you're trying to build and what that user in that moment needs. And as such, the JavaScript in the HTML can change as well. Hopefully, the gears are starting to spin in your head as we go along.
And now that I start looking at this code this way, I start spotting some like optimization opportunities and just opportunities to simplify it that I wouldn't have noticed otherwise. For example, again, we want to make this function synchronous. We want to make the click handler synchronous. So I'm going to remove this async, but I have these awaits, right? Like I gotta put them somewhere. Well, you know, in React, there's like this thing you sometimes do, which is called lifting state up, where you put the state into a parent component and then you pass it down. What if we could lift data up, and instead of lifting it to a parent component, we lift it up to a parent computer. So we'll lift it up to the server. So I'm going to just copy and paste this from here. I'm going to put it here.
I'm expecting this to be another one of those moments where it clicks for even more people. If not, no shame, by the way. This is, again, a really new concept that's being done in a really cool way here. But for a lot of y'all, I see it in chat, This is a moment. Oh, click. What he just said really sums it up. Y'all are starting to see, okay, that makes sense. Yeah, this feels like a full circle moment. It's clicking, yes. Echoes of Ryan's, just move it up to the server in his React router. Yep, y'all are starting to see the light, and I'm honored to be one of the places that gets to help with that.
And it also became colorful. It was all green before. This like green font just like reminds me of the the Matrix movie, where you can just like see, like when you're inside, you think this is the real world, but actually like no, like this is the real world. You're on the server.
The server is the only thing that's real. Everything else is made up and full of shitty Chrome extensions.
Okay, so let's see if this worked. Bam, it doesn't work. Well, it doesn't work because I need to, now that this fetch is happening on the server, I need to actually specify, what the host is, because it can't guess it, I guess. And so if I press reveal again, it doesn't work because it says reference error, JSON is not defined. So if we look here on the page, of course, I'm
going to pause a second to let anybody who hasn't quite had it click yet. Hopefully you can see the magic of how we get the JSON variable over to the client code here. This might be a good moment. If you can guess right now what's about to happen, the gears might start spinning a lot faster.
Using this JSON variable, but it's actually defined here. And if this was a regular kind of nested function, that would just work, right? Like that's just a closure. But what we're trying to do here is more like a closure over the network. That's weird. How do we make this work? Well, one way we could do this is, what is the purpose of JSON? Like that's the stuff that you can send over to the network. So this is a program that sends another program as a piece of text, as a string. So we can turn this JSON into a string in order to send it together with our program. So I'm going to call json.stringify. Yay. It worked.
I know this is the exact timestamp where it's going to click for a bunch of y'all. Let me know in the comments if I was right. Passing the JSON as a string template to the HTML string in order to embed data you got on the server in the client so you can use it for whatever you want to use it in on the client. Hopefully those gears are spinning now. And again, if they're not, don't worry. This gets much more clear as we go forward.
And notice something interesting now is I load the page and I press reveal, and there is no network request. And the reason there's no network request is because, well, the data is already there. It's already on the page. This is kind of an interesting way to think about client and server, and I'm just going to continue down this rabbit hole and see where it leads me. So the other thing I'm noticing is, okay, like when we hit the server and we want to serve this page, the first thing that happens is that we...
Okay, I already see a misconception in chat, so I have to dive in. This is just server rendering. This is how all web dev was 20 years ago. Neither of those are true statements. Because when people say rendering, they're assuming it's just the part that's visual that comes out, not the part that's interactive. The thing that was just showed is dynamic behaviors being defined by the server. The actual JavaScript code, the part that is interactive, is modified based on things the server does. And we are writing a different template with different JavaScript and different behaviors to the client on the server side. That's the difference here. Other solutions that have existed forever always go back to the server to say, hey, what should I do next? Hey, what should I do next? The idea of the server describing JavaScript to tell the client what to do is something we used to hack into PHP, but that's the magic of this new concept. Hydrate is kind of this. We'll get to hydration in a bit, but that's not where we're at yet. What's going on here is dynamic generation of behavior. The JavaScript code is changing based on what the server needs. Not needs, based on what the server tells the client to do.
The other thing I'm noticing is, okay, like when we hit the server and we want to serve this page, the first thing that happens is that we call the API, but where does that happen? Well, we hit the same server that serves this API, it returns to JSON, and it returns it like this. And I'm like, do I really need an API for this? Like maybe in some cases, but probably not in this case, because I only have one usage. So I'm just going to paste this code here, and I'm going to delete this API handler.
Remember when Dan tweeted, you don't need APIs anymore, so I could clickbait it for a thumbnail? Like, he actually tweeted that with the knowledge I would abuse it. He wasn't joking. In so many cases, the idea of an API is just not a necessary abstraction anymore. We don't need to expose data via URLs if it's only being used to render a UI. We can just do the thing the API did and render the right UI with the right context.
Let's verify that it still works. And, you could say maybe, what about abstraction? Like, what about separation of concerns? But I can always, if I don't want to have this code in line here, I could always pull it into another file. I could put it into a module. I could give it a name. The API was not really enforcing separation of concerns or anything like this. So we still have tools to do this, and we can still extract this thing if we really want to do that. All right. I forgot what I'm supposed to do next.
Okay, he made two mistakes. He got a tiny bit lost here, but
Oh, right.
Something he confessed to me and a few others after the talk is that despite putting a lot of work in and doing a bunch of test runs, he had never done a test run from start to finish successfully for the talk before doing it live. And then he did it live, and it nailed it perfectly. He was so hyped. After this talk, like in the middle of the next talk, he walked by, I gave him a fist bump. I shit you not, he did a little jump for joy as he was walking to his seat. He was so hyped. I haven't seen him smile that big. He knew he nailed it, and he did nail it.
So there's another thing we'll notice if we look at the response. So what's happening right now is that the list of cat names is inlined in JSON, but it's actually pretty long. But now that we have a whole picture of what's really happening, including both the server and the client side, we also kind of see the relationship between how the data flows from the API into the component, into the client code, and how it's being used there. So I notice that the cat names from here flows here, and then I select a random one from them, and I really only need one of them, so it doesn't make sense to send all of them. So maybe I'll just take these lines and I'll actually move them up, and I'll extract them. I'll put them here. So this is something I can do ahead of time on this computer, and I can pass the cat name instead through JSON. And so now if I refresh the page and I press reveal, it still works. But if I look at the data inlined on the page, it is only data for this one single thing.
Starting, hopefully, to click for y'all. The ability to move your logic from the client to the server as you choose by just cutting and pasting it across different places is still something that feels magical every time I rewrite an app to use these new patterns. The idea that he just took this logic that was running on the client and just cut and pasted it up, and that's all you really have to do, is magical. And once we get into components and props and how these things work there, me even mentioning that now might have just made it click for some of y'all. Again, let me know when it clicks.
And so I want to kind of take, I've done a bunch of changes to this file. I kind of turned it inside out a little bit. And so I want to take a look at the result. What is the shape of this thing? And you could say it's pretty messy. I think that's one possible reaction is, oh, this looks like some code I wrote in 2003 with PHP and interpolating strings and just passing things, kind of like a mad scientist. But if you're kind of functionally brained, maybe you'll think of this as, oh, this is kind of partial application of the network. There's this concept of applying a function in several steps. And this is kind of like this, except that there's also a network step in between, which is kind of interesting. But I think the main way I kind of look at this is that we've removed all the boundaries that are inessential to the problem.
That sentence kills me. Oh, it's so good. It's the magic here. I say this a lot, and I'm going to keep harping on it until it clicks for everybody. React challenged the idea that model view controller was the right way to split up your application into boundaries, and said, what if those were arbitrary distinctions? What if those lines were just things we invented? And what if you could invent better lines for the way you want to build? What if you don't even need them in the first place? What if the boundaries that existed for all this time were somewhat arbitrary distinctions, and we could just move things across them whenever we felt instead?
Which is kind of interesting. But I think the main way I kind of look at this is that we've removed all the boundaries that are inessential to the problem. We've removed all the boundaries that we can remove, and the boundaries we're left with are just dictated by the laws of physics. So this code executes first, like it has to execute on this computer, and then it emits this code that will have to be sent to another computer, and it will execute later. And then we can pass some data together with this code. So that is really the fundamental shape of the problem. No matter like which library you're using, which approach you're using, it's going to kind of look like this, like when you strip it down. So there are these like two different worlds. Like this code executes in one world, and this code executes in another world. And what I like about this is that there is a very clear separation of how the data flows through the application. But of course, I wouldn't actually want to write code like this way for two reasons.
Be careful. You might annoy the PHP people who still think this is the right way to write code.
So one reason I wouldn't want to write it this way is just because I don't want to be writing code inside of a string. Like, that doesn't make sense. I want to have like syntax highlighting. I want to have modules. I want to have type checking. So this is not really, something that I would like use in production. And the other problem with this code is it's probably going to get very complex very fast. So if I keep layering on more features, even if I want to display this button multiple times, I will have to add a bunch of stuff here.
I didn't know he said the multiple times thing here, because I mentioned that when we chatted. I didn't think he emphasized that point. I must have just missed it when I watched live. I think it's one of the most important parts, because this all looks good and fine right now, but what happens if you want two of this button? Quickly, this falls apart if you want two buttons instead of one. Unless you want to just rewrite all of that code over and over and manually set identifiers and do all that shit. Not fun. What if the piece itself was composable?
I have to add a bunch of stuff there, and I would have to somehow like connect them together. So wouldn't it be nice if we had some way to split, like a function into other functions and like give them names that correspond to product features? Wouldn't it be nice if we had like a concept for this so that we wouldn't have to have this like single big function? So of course we have this concept, it's components. So maybe we can take a look at how code like this could look like in the component world.
Before we go to components, I'm getting triggered by chat. If the person I'm about to roast doesn't want to be in the video, tell me and we'll remove it. But this is the really stupid question I'm incredibly tired of getting. The reality of what he showed earlier, if you remember, was that the server generated and sent an HTML page to the client that then had to make another request to the server to go fetch the data from that text file, put it in JSON, serialize that JSON, then send that response down. So the server, even in this really basic, minimal, best case example, had to do two requests and process two things. So it has more time it has to spend doing the stuff, because the additional overhead of making of receiving a request and sending the response already makes it so two requests is worse than one, especially when you consider how light a lot of these rendering tasks are. Then when you consider the fact that every request probably has to be authenticated, that's more cost. If you have to do 3 additional requests, you're authing 3 times instead of once. That sucks. If you have to make multiple database connections or you have to make multiple queries at the same time, the amount of redundancy inherent to letting the client do the work means that now the server has to send way more data, way more times, be way more redundant. If you load like the Twitch homepage, you now have to deal with like 15 plus queries happening once the JavaScript loads. And each one of those queries needs to be authenticated, processed, generated, database connected, services managed, and responded to. If you just have one request that streams the rest in over time, it becomes significantly cheaper every time. Going from n requests to 1 request per page load, even if you're also running React during that step, is almost always going to be significantly cheaper in terms of the stuff that you're doing on the server and the cost of that. It just, I'm sorry this one frustrates me as much as it does. It feels so obvious to me. But when people see code on the server that could have been on the client, it's like, oh my God, you're just trying to rack up our server costs. No, the things that are expensive on servers are how often they're invocated. And if you can knock down the number of invocations exponentially, having a 10 to 20% increase in how long one response takes, that's not where your cost model is coming from. Your costs are coming from a place entirely different. It's just a fundamental misunderstanding, and it's one that annoys me. Anyways, sorry for the roast there. I really want to kill that misconception because it's so far from reality that it frustrates me. So had to jump on that. Sorry to the poor chatter I just roasted. It's just the question I see the most that seems to be the most fundamentally misunderstood. Less requests will almost always be way faster. Oh, somebody made another good point. Like, this is why we have GraphQL. A lot of why server components work is because, how do I put it? A lot of why server components exist is what they learned from GraphQL and specifically building Relay at Meta. If you're not using Relay with GraphQL, you're probably using GraphQL somewhat wrong, if not like very wrong. The magic of Relay, when you're compiling the exact data structure a page needs so you can do it all in one request, is actually magic. It's so powerful, and it solves a lot of these same problems. Building it, implementing it, maintaining it, getting it to work properly, and getting everybody to understand it over time was so painful that in the process of trying to make a more understandable version of Relay, one of the directions that they went in ended up becoming server components. The guy who announced the compiler for React, the guy who was on the front of the stage when that happened and helped run the team and make a lot of the decisions, Joe, was originally on the Relay team. And a lot of his learnings came from the stuff he built for Relay. The idea of your application inline describing the exact data it needs so it can get it in one request. You write your app once with React syntax, and then it can generate the data it needs as a template. GraphQL is one cool way to do it, to load the exact data in one request. But what if the components themselves could do it? That's where we're going now. Sorry for the tangents, just nerdy about all of this. Can't help myself. The difference between Relay and Apollo is that Apollo is like, Jank would be putting it nicely with Apollo. It's not trying to generate one query. Every Apollo app I've ever used takes minimum 5 queries to start showing you content. Relay has a compiler so that the query becomes a single thing that fires to load all of the data for the page. Apollo is just a shitty way to do a bunch of REST requests, effectively. It's just a different syntax for fetch, whereas Relay is a compiler for data loading in your React applications. Fundamentally different. The only thing they have in common is that it's GraphQL and they work with React with hooks. Otherwise, they're just fundamentally different. So like Relay is closer to server components than it is to Apollo. Apollo is closer to like putting a bunch of React queries in your application to fetch data from all sorts of different places. Huge difference. And if you think Apollo solves these problems, you don't fully understand Apollo. Not saying you do. Saying that like GraphQL can solve this if you use it the way no one does, which is Relay. GraphQL doesn't solve this if you're not a deep Relay-brained person. I've even said many a time, the only people who actually have set up Relay properly have PhDs in graph theory or are Meta employees. There was one exception, which was Jane Wong, because she's a wizard and had built some really cool stuff with Relay on her personal projects. But now she works at Meta. So again, my rule stands. The only people who actually know how this works have PhDs in graph theory or work at Meta. Chaos. Server components are the GraphQL Relay compiler type thing for the rest of us, with much better behaviors around HTML, much better behaviors around templating, much better behaviors around bundling, and a whole new potential ecosystem of tooling. This is like Relay was the first step in this direction. Server components are a massive leap. Now that I've adequately tangented, let's go back to what he had just said. I'll rewind a little bit so we have our context again.
Split, like a function into other functions and like give them names that correspond to product features. Wouldn't it be nice if we had like a concept for this so that we wouldn't have to have this like single big function? So of course we have this concept, it's components. So maybe we can take a look at how code like this could look like in the component world. So we're just going to pluck some pieces out of it and see how it shapes up. So the first thing you do with the component is you give it a name. So I'm going to call this one cat name generator, because that's what it does. It's going to be, I'm going to need to export that, and it's going to be an async function. And I'm going to need this read file thing. And I don't need this URL part, so like I'm really kind of zooming in on like this particular part. So I won't need the body tag. Like I just want this kind of focus on the logic of cat name generator. And so it's pretty clear that I'm going to need all of these pieces. So I'm going to copy and paste this. And then I'm supposed to do something with them, but I'm not sure what yet. So I'll wait a little bit. And then let's have a look. What do we have here? So there's a bunch of HTML stuff that like seems kind of irrelevant. But then this reveal button, like that is definitely a part of what I want to render. And it has a click handler, and this click handler depends on some information actually. So this information, this JSON, it's already known by the time any of this code in this inner world executes. So I can kind of pluck it out, and I can just put it here, because it doesn't matter. It's like available on load. And now that I kind of look at this, like I see here's like the input to this code, and it kind of looks like a React component with props. So I'm just going to put this as a prop here, and I'm going to copy and paste this event handler. Let's see, and I'm going to copy and paste this button. So this will be a button. This is JSX, it's not HTML, so I'm going to need to change the syntax a little bit. And I'm going to need to give this thing a name. So here it doesn't have a name. I'll just call it reveal button. And there's my button. The next logical thing that I want to do is I just want to pass, I need to pass information from the thing in the outside to the thing in the inside. I think it's natural to kind of think of this as, well, I just want to render a reveal button with cat name. So is that all, or did we forget something?
Hopefully it's starting to click for people a bit more here. If not, totally fine.
So is that all, or did we forget something? I think we forgot something. What about all this green stuff? Like there's something there, right? Like there's some kind of a hard boundary that is dictated by the laws of physics. That is, these really are two completely separate worlds. Like this code could execute it could execute on a different computer. It could execute much earlier. And just like, the past me who prepared this talk and the present me who's given this talk cannot be in the same room at the same time. These two components cannot be in the same file. It breaks the laws of physics.
This was a thing that was a really hard click for me early on, because a lot of the solutions I had played with, like Pages Router in Next.js or loaders in Remix, what those patterns did is you would have server-only code and client-only code in the same file, and you would trust your bundler to be the tool that would separate those pieces. It's weird to put it this way, but server components are the first full stack model where client and server are so tightly coupled together that doesn't have that problem, that doesn't try to co-locate server and client code in the same file. You have a really clear distinction between file boundaries of what's on server and what's on client, while at the same time getting to interweave them in such a powerful way. One more misconception I've seen a bunch in chat that I want to jump on here. People are wondering, what do you do to get the data when you're generating this HTML? Do you call an API still, or do you use like an RPC layer instead? You don't have to do any of those things. You can do any of those things, but you also can just run the backend code here. If you had an API that was connecting to a database to get some data via SQL and then returned that as a JSON response from the API, you call the API here, or you could just call the database request here. Or what I think the best solution is, have a folder in your code base that's your server logic folder, and have a file in there that exports the function that does that query, and you just call it here. It's not an RPC because it's not a different server from this server. The code on the left here is just your server. It can do whatever you would do in an API, but instead of the API returning JSON or even the endpoint returning HTML, it returns the magical React server component structure that has HTML as well as server components that can be streamed in, as well as client components with all these behaviors. That's the magic, is the API can generate the right user experience rather than generating the right HTML or JSON.
So what do we do? One thing I'm going to do is I'm just going to embrace the fact that these are really two different programs in a way. These are two programs that execute in separate environments at different points in time. I really shouldn't think of them as a single thing, which sounds contradictory to what I was saying before, but
this is probably going to be one of the challenging points. And there's probably a few of you who thought it clicked earlier where you're losing it a bit here. That is, again, totally fine and acceptable. This is a new concept that takes a bit to click, but these are the two computers on the right here. The computer one is the server, which is an async generator component, so to speak, that does all of this logic, but then it mounts the client component, reveal button. The client component sends the JavaScript to the client so that when you interface with it, it is actually there to run. None of the JavaScript code here, none of the code here, none of the code in this first file up top ever gets to the client ever. This just runs on the server. By returning the reveal button, it is now told to the bundler, the compiler, the server, all these things, hey, this component, if it's a server component, run it here. If it's not, run it here, bundle it, and then send it to the user so that they can keep running the code afterwards.
There is some kind of a hard boundary between them. And so if I think of, this is a completely separate program. So like this program executes on the server, and if it imports something, then that will also be there. And then this is the stuff that executes in the browser. If it imports something, it will be there. Well, how do I pass information between them? So how do I pass information here? Like here, I kind of enter a string. There's like a place where I go from one world into another, and I can carry something with me. I can carry some data with me as I do that. And so what if there was a way to say, yeah, these are two separate programs, but you can open a door between them, and this door only works in one direction. It lets you pass things from the past into the future, and only things that can be turned into text or JSON or serialized can pass through them.
I'm going to let that one sit for a second, so maybe it might click again for a few of y'all. The crazy magic here is that one-way door. We're going to get to it in a second, but as people are already seeing in chat, there's a specific directive that is that one-way door.
So let's add a door.
That's what use client is. It is a door from the server to the client, where the server now sends behaviors to the client rather than just HTML.
The door. This is the green stuff. You know, like in Matrix, like when you're outside, you look at these green screens and you don't understand what's going on. But then when you're inside the Matrix, you kind of like, it's just like everything looks normal.
For those who have been looking for the how is this different from PHP moment, here you go. Nothing before this. And I mean nothing. As someone who's deep nerdy about all of this, I've never seen anything do this like this before, where the mental model on the server and the client is the same. The way you structure your components, the way the hierarchies work, the way all of this happens is the same, but you're opening a door for behaviors to be sent to the client in this dynamic and composable of a fashion. This component isn't reusable yet, but we'll get there in a minute, don't worry.
So we've just entered the matrix. So yeah, let's verify that this actually works. So I'm using Next.js here, but this example would work in any framework that supports React Server components. And I have the reveal button here. I press it. I see the result. And again, let's verify that it actually works like we expect. So I refresh the page. I press reveal. There is no extra network request because all the server part, it has already executed. And if we look at the HTML, there's a bunch of stuff here. But somewhere here, there are props with the cat name. So this is the stuff that gets passed through the door.
And to be clear here, that prop, that data there, in the end, is just embedded in a script tag on the HTML page so that you have access to that as like a variable inside of the JavaScript code. You're just effectively, when you pass a prop to a client component, it is embedding that data in a script tag so you have access to it later when you're doing things on the client. This is how it used to work with PageRouter and with the old Next.js and even the current Remix patterns. But you had one loader per page. So you would say, I want all of this data to be available on client, not I'm passing this data to this component in this place. That is where this becomes magical, because if we render a bunch of these buttons, we can do a bunch of things. At the end of this, I'm going to fork it and show what I mean. So we're going to finish the talk, and then I'm going to go do that.
And so why would we want to do this? Well, one reason is that now that we think in components, we can do all the things that we can do with components. So we can nest them, we can render multiple of them, and each of those components can have these kind of points of handoff where we can pass information from one environment into another. So I'm not going to show that, but there will be plenty of talks today that kind of focus on these ideas. So do check them out. And I really want to just go back here for a moment and kind of just like recap what's going on.
Before he goes to the recap, I want to play with this a bit more because we have more digging in to do. That's my role here. Take what he did, riff, go deeper. I'm not just here to re-show his original talk. I want to play. So let's do that. Let's npx create next app at latest. I'm going to bun it just because it's faster. I'm so tempted to hit no on TypeScript this one time because he didn't, but we'll just go with it. Cool. So right now we have this giant page that is a bunch of things that I don't want to use. So we're going to make a folder. Let's name it components. And in here, we will have cat generator.tsx and reveal button.tsx. Note that I'm not putting use server on top here. I'm showing it so I can explain why, because use server is how the client sends things to the server. It's not defining a server component. The use directive is for when client sends things to server or server sends things to client. So use client is so the server could send JavaScript to the client. Use server is so the client could send JSON to the server. So we don't need that for server components. I still think, and I'll continue to die on this hill, this should have been named use action, or I would K for use server action. And then in the future, when use server does other things, we can just delete the word action for it. But it would have been much easier to explain this if use server action was the name. The guy who taught me a lot of what I know about React, who's been maintaining the Twitch code base for almost 8 years now, he was really confused about this. And it was a big part of why he wasn't fully understanding of the new React model, because he thought use server did something different than it did. It's a door back to the server. Thank you, whoops, wait, what, for the good phrasing there. We don't need that here because the client's not sending things to the server. The client's getting things from the server. So we'll put the door somewhere else. Let's make a quick cats.txt. Get some real good cat names in here. Murphy, Miles, Dan Abramov, Ryan Carniato, Soy Kotick. I think those are some good cat names. Export, default, async function. My autocomplete thinks we can use hooks in here, which is another important detail. Because the server is generating HTML, it's generating something static. So things that change, like hooks, can't be used in here. Hooks are, once the behavior runs on client, things that can change. We're just generating a template here. So this example of use state, we can't do that. We need to get some stuff though. Specifically, we need FS, but I want FS promises because screw using FS without promises. So it's just going to import read file from it. That makes sense. Read file from FS promises, const all cat names. Cool. Decent code gen. Again, super maven is dope. But now we have the cat names, const random cat. Cool. You get the idea. Now, if I take this cat generator function and I just replace all the contents in the page.tsx with cat generator, I also have to import it. And then we'll bun run dev, localhost, as long as I didn't accidentally leave something. Cool. I load the page and we immediately get a cat's name. But we want it to be under a button. So we don't want this to be like that. We want that reveal button. So I'll open this next to the cat generator just so we can see these things directly with each other. As I said, this has to be use client because we're sending JavaScript to the client. This is effectively just sending HTML, but since this is sending JavaScript, we specify use client, which means we can do a lot of things. I'm actually gonna do them a bit differently than the code demo because the way he wrote it, if I go back to the YouTube video, this only works with one button, but if I wanna have multiple buttons, then I have to do things a little differently. So I will export function reveal button. I'm gonna delete all that for now, just auto-completing, because what we need is cat name string. So now we need to return something here. Button hi. And I'm going to switch this return to be this instead. It's going to type error because I'm using TypeScript and we haven't given it a cat name. So we'll give it the cat name random cat. Cool. Hopefully this is pretty clear now. We have the server-side logic. This is almost like an API that's getting this data. Instead of reading a file, it could be fetching it from a database, doing something secure that you specifically want to limit to be on server. And then it renders this component that we're using on the client. Previously, on click, he would change the DOM, but we're going to do it the more React way. We're going to do const, look at that autocomplete. Man, I love Super Maven. We have to import the use state still, so we'll do that. Show, set show. I'm going to change this to revealed, set revealed. Be a little more idiomatic with the name. So if revealed, let me grab the HTML we had here before that was generated. So it's actually decent. Yoink, get that back the way it was. If revealed, return props.catName. Otherwise, button on click equals set revealed true. So this button gets passed cat name as a prop. This is instead of fetching it from an API or embedding it manually in the script tag or doing all the other things that might get cat name to this component. Instead, we just pass it as a prop. The thing passing it happens to be a component that is running on the server. But that is so much easier than fetching from an API, hoping the data comes back in the right format, making these things reusable. All of that sucks. Let's just make sure it works before we go any further though. Should I make this button a little more of a button? Class name equals text 2XL, font bold. Sorry for the tailwinding. It just makes life easier. Cool. Now it looks like a button. I'll make this reveal instead. Cool. And to properly honor the way that this was before, I'll do everyone's favorite task, centering. W screen, H screen, flex, items, center, align middle. I'm just gonna do all of them. Cool. And look at that. It all works. So what we're doing here is we're passing this data to this component. This data is always there. Doesn't matter what we're doing with it, it's here. I'll show you some cool things we can do with it in a minute. And when we click this button, it sets the state on the client to true, and then it reveals the text right there. And this is all just coming from another component that mounts it, cat generator. So in here, we fetch from the file, we pick our cat name, pick a random one, and then we return that as a prop inside of the reveal button component. So now if I want more of these, I can just have more. All flex column and gap 4, so there's some space between them. Now if I reload, we have these 4 things. I can click them, and each one reveals by itself. I should probably clean up the JSX a bit here and just have the H1. Look at that. Each of these is effectively its own endpoint getting its own data. Super, super cool. I hope that by now these patterns are starting to click and the magic of server components is starting to be a little bit more visible here. It's all composable. We can just make multiple of these. Ready to see where things get real crazy though? What if we want to pass children? What if we want to render an entirely different component when this changes instead? So instead of just cat name string, we can pass it children react.react node. So now this is expecting children. So we'll give it a child. We'll just put a div child component. And if I want to use that inside of the reveal button, it's just a prop I can use. So if I want this to be the default state, I can do that. I'll put props.children. And now when I see this here, child component is being rendered because that's what I'm passing from here. I could even pass a different client component here or a different server component here. This is where the magic really starts and nothing else comes close because I don't have to have this here initially. What if this is what I'm passing for the reveal state instead? I'm going to undo that delete. I'm going to yoink this guy. We're going to pass this as the child and we'll delete random cat because we're just going to put it in here. Now, if I go back here, I can delete cat name and we're just passing it children the way you would with anything else. And I can get rid of all that and just return props.children. And here I'll change it to reveal again. And now what we're getting is server rendered HTML being passed as a prop to a component to render. So you don't even have to pass data. You can pass markup or even pass another component. If I wrap this with like React confetti, then each one of these would send a JavaScript down. If I wanted to make this a counter component too, which is everyone's favorite, let's make a quick counter. Counter.tsx, use client, export, function counter, yada, yada. Typical counter, I just let autocomplete do its thing and it seems to have done a good job. If the reveal is instead for a counter, which I can just change the child here to be counter. Now when I click reveal, I get the counter instead. How cool is that? That I am passing properties, I'm passing components, I'm passing behaviors through a server component to a client component. I can pass server components here, I can pass client components here, I can pass data as a prop, I can pass anything you would normally pass in React, but I can pass it from the server to the client instead of having the client have to fetch it from the server, which is the way we would always do this before. All of the different ways the client might want to see things, I can render on the server ahead of time. So if I have like a tab component where I have 3 tabs, all of the states are being rendered on the server, you just click between A, B, and C on the client and you just change what renders. It's magic. You can use conditions, you can use components, you can use composition. Everything is as flexible as you would expect from a client-side or a just server-side framework. Specifically, it's as flexible as we expect from the composition model of React, but now it works in the server too. It's so magical and it makes so much shit so much simpler because I promise you, reading from a file asynchronously, splitting the names, and then just passing the value down as a prop will always be significantly easier than the way we did this before, which was fetching it from an endpoint instead. It's magic. And nothing else right now does this. There are a lot of frameworks and a lot of solutions that have parts of what are here that have the user experience for the most part here. But these concepts, these things that we do as developers, the idea of the API, the HTML, and the React code bleeding into each other the way you choose for them to is actually unique. And I haven't seen anything quite like it before. There is no equivalent to this that I would expect anyone else here knows of. This is a truly novel, magical thing. I love the tab bar example too much to not show it quick. I think it really highlights the magic of this model. So here I have the tab bar component. This is a server component that has these 3 children. These could be something much more complex, and in most cases they will be. Imagine that this is something that's like syntax highlighted code that you want to show in your documentation. If you send the whole syntax highlighter all the way to the client side that has all of the possible ways the client might have to deal with that data, that has every language that you might be rendering here, sending all of that JavaScript to the client so that it can render and match the server code sucks. So what if we only only ran that on the server? What if each of these components was actually really slow to render, but we could just skip that and do it on the server instead? Let's take a look at the tab client code so you can see what I mean here. We have A, B, and C are all React nodes that are being passed to tab client, and we have a pretty simple set state here. Use state can be A or B or C, and it starts with A. And we have a bunch of buttons with a bunch of copy-pasted Tailwind code. By copy-pasted, I mean generated by SuperMaven. And we change to text white if it's selected, and we don't if it isn't. And then here, we have A, B, and C. So these are the tabs, the buttons to select them. And if active tab is A, we render A. If it's B, we render B. If it's C, we render C. Cool. So now we have A, B, and C as our tabs, and it renders whichever we have selected there. The magic is that whatever happened in this file, in the tab bar file, it doesn't affect the client at all. Everything that happens here is specific to the server. We're effectively sending these different HTML nodes from the server to the client. So we're not just sending one HTML document with one set of script tags. We're sending all of these different HTML partials that the client can then toggle between. When I click and I switch between B and C, nothing happens. If I add a console log in here, console.log, rendering tab bar, this code, this console log, will not appear in the browser. I reload the page, I click between these, nothing is re-rendering. I go to my console, we see it in here when it renders on the server side, but if I go and click it, it doesn't run again because it already generated all of that HTML, it sent it to the client. So now I have that if I want to use it later. And you can get crazy with the patterns here. You could do something slow. Like let's say we have async function slow cat name component. So we'll await 1 second. Then I'll copy this cat name code here. It'll return div random cat. Cool. Need to import read file from its promises. Dope. So now I have slow cat name component. I'll just swap B with that. Why not? Cool. So now I have this slow async component. But when I load the page, it doesn't seem to be affecting things. I would expect it to take a little longer to do that. This might be because it's not force dynamic. Let me go turn off all the caching quick. Const equals force dynamic. Hopefully that will make it as slow as I would expect it to be. I can also just go bump up the wait time on that. Let's make it 10 seconds instead. Is that not the right thing? Is it have to be exported? Okay, why is that not? That should be taking a lot longer to load from my understanding. If I change it to be component A, will it be? Okay, which I'm so excited that the next version of Next is gonna just kill all of the caching. Export, const, revalidate, 0. Am I missing any of these other things to turn off all the caching forever? There we go. Now it's taking its time to load. See how long this page is taking to load? The reason it's taking so long to load is in order for these components to come in, it has to generate them. Even if I'm not showing the slow cat name component and I reload this, so see, you can see the loading bar here. It's taking a while to load this page, but we're not showing that data initially. What if we didn't have to block on it? What if we told React, hey, by the way, we can deal with this later. If we wrap something that is slow in suspense, we can even give it a fallback, which is, in this case, I'll say loading. So I'm going to refresh the page. I'm going to wait the 4 seconds, and that streamed response still comes in. Now that we've waited that time, it'll be there immediately. But if I refresh again and click, it's going to still be loading until it comes in. Streaming data isn't just the thing that you're immediately rendering. Streaming data can be a prop that you pass as well. Streaming and suspense lets you say, by the way, React, put this as the temporary thing, and whatever happens underneath, send it when it's done. We don't have to block for that. There is no framework in existence right now that has this built in as a composable primitive. This is the only thing. My research guy just made a really good point, which is that I should show this in here as well. If I refresh, you'll see this one really long request. That's the HTML stream where more data comes through over time as the rest is done. And you can see the initial response is small. It'll actually expand as the rest gets in because the additional tags, the additional information all comes in when it's ready. And here we can see div null children soicotic. This is the additional bit that came in. So when I click B, it's going to be soicotic. So now if I click here, you'll see we don't have a tag for this. We might have the loading state in here. We're not going to have anything else. Yeah, it's just all the generic props. But now that it's done, if I scroll back down here, we'll see children soicotic again. That is the magic of streaming, is the additional data comes in when it's ready, and React will show it to you when it's ready and show you the loading state when it's not. It is magical. It is so powerful. And I am pumped that this is just part of React now. So cool. One more good question I just shot in chat, which is what happens when you press the button? Nothing happens. Because when I press the button, I'm just switching between props. So like if we weren't using server components, we just had all of that data on client, clicking the button wouldn't do anything because nothing new is happening because the data is already there. I showed it to you in the script tag in the HTML. It knows what data it's switching between. And this code is client code. This only runs on the client. None of this code runs on the server, fetches from the server, or has anything to do with the server. This code is code that has these three states. It has A, B, and C as different things we pass to it. And it has the use state, which lets us click and switch between those three. It's really cool for that in particular, because now once the server is done rendering these things, I can toggle between them and it's effectively hot swapping out B when it's ready. So again, I refresh, I click this, it's loading, nothing happened in the network tab. I can keep clicking, nothing's happening in the network tab because we're just waiting for this 10-second long localhost stream to come through when it's done. And then when it does, it auto swaps this over to the right thing. Nothing else has this. This is a new, incredibly cool and powerful methodology and mindset. Nothing's done this before. Effectively, B and C are coming through as just strings here. So cool. Anyways.
What's going on?
Back to the talk.
So we're used to thinking about the client and the server as two separate programs, but we can also think of like rendering a web page or rendering a UI as a single program that's split between two computers. And when we look at kind of vanilla JS representation, the way this works is that this part executes in the server world, and then it emits a program that will execute in the client world. And there is kind of like a hole through which we can pass information, but only things that are can serialize to JSON can pass through that hole. And so the program is complete after both of these phases have run. And so if we look here in the React version, again, we have the server, we have the part that lives in this world, and it can prepare a bunch of data. And then it can choose, there is a door here. So not every module would have a door, but if there is a door, this module is kind of saying, I can accept props from the server. I can accept props not just from above, but from capital letter above. Like I can accept props from the past, from another computer.
I love this so much. In the highlighting here of how these things on the left and right are so close to exactly the same. On the left, it's a little more obvious if you've written server code because we're writing HTML and we're embedding a script tag with embedded JSON in it. But what if instead of having to do this crazy string modification stuff, we had a model where we could compose components the way that we do in React traditionally, but we just call them from the server instead? That's the magic here. Instead of having to string interpolate and only go one way, we now have all the composability, all the benefits, all the type safety, all of the ergonomics of React, as well as a ton of additional superpowers along the lines of things like streaming, component hierarchies and ownership and composition, passing server components to client components as properties, a lot of things that theoretically you could build in the vanilla solution on the left, but suck. This is the world's best version of server-rendered client behaviors and server-defined client experiences, because it's still a client experience. You're still sending JavaScript that you wrote to the client, where something like LiveView, LiveWire, HTMX, all those solutions, those have one JavaScript file that's already been written by the people who made that framework that gets sent down and then talks to the server to do all of these things the other way. This is the server creating the right set of JavaScript and experience that is unique to your application. Every Next.js app, every Waku app, every Remix app, all these apps, even if different people build the same app 3 times, even if it's in the same framework, the code will be different because they wrote different code. If you look at an HTMX app, they all have the same JavaScript. If you look at a LiveView app, they all have the same JavaScript. The thing that is dynamic is how the server tells the JavaScript to do things. What is dynamic here is the JavaScript itself. Fundamentally different and fundamentally more powerful, because if you can write the client code yourself, you can write better client code, you can write more specific client code, you can write things that create a better client experience. But now we also get all the benefits of HTMX or LiveWire or all of those solutions too. That's the magic here. It really is the best of both worlds.
It's like an information wormhole. And like this is kind of the second stage of this program. Like this is a program with two stages. One thing that's kind of interesting here is that actually, for practical reasons, on the server, you want to run both stages because you want to generate the initial HTML. So you run this stage with the initial state, and then that gives you HTML. But then on the client, you might want to, this is the part that can update and re-render in response to state changes. So
that's one more point I haven't touched on enough that Gabriel has pointed out I probably should. Just because this says use client, what this does not say is use client only, because this code runs on server and on client. If I put a console log in here, it's console.log rendering the tab bar client component, and I'll go delete the one from here so it's less confusing. So we have rendering the tab bar client component. If I go to here and we check the console, obviously we're going to see this here because it's happening on client. What you're not seeing is that it also happened on server, because in order for the HTML to come through correct and have the right data before JS has loaded, it will run your client components on the server once to generate the right HTML. So we see here all the things that came from that component. I'll just open this in my editor. I just copy pasted the content here. You'll see all of the HTML that I rendered, the flex, the buttons, the current tab. It doesn't know what the other tabs are. This is just the HTML for that default state. But we have done this separately from everything else because you might want to see this stuff early. In fact, you probably do. If you had something in here that you only wanted to run on client, like let's say you're accessing like window.local storage. Window.local storage does not exist on the server. So if you want that to be restricted, you can, but that's a problem for your framework, not a problem for React. The way you would do that here is you would use the dynamic. So const dynamic client only tab bar. Look at that autocomplete. I have to import dynamic from next dynamic, and we import client and SSR false is the use there. The one catch with dynamic is that it has to be the default export for this to work. So export default tab bar client. So I'll delete that. We now have a dynamic client only tab bar. So when I load this, technically it shouldn't be showing this immediately, but I think it has things cached, so it is. Might also be taking a while to regenerate things. Yeah, so now when I load the page, it's empty until this loads in because the client has to render this itself. The HTML we got back from the server, if I open this again, it no longer has those elements in it because those elements were only part of React code that was running on the server. Now it's not running on the server, we get back nothing. So since the tab component is now SSR false, this will only run on client. We're still sending the code to the client. We're still passing these props to the client so it has them. All of these things still run on the server, but this code now only runs on client. If we don't SSR false it, then it will immediately load on both environments and will still run on both. The magic here is that you get UI immediately, and with React 19, it can cache things like your click events until the JavaScript loads later, if the JavaScript takes longer to load. Or if you do something like on the dynamic client only component, you use window, you can if you turn SSR off. But you almost never want to do this. I've seen very few code bases that actually wanted this that weren't like a video call app, which, by the way, I've used this for a lot. But if you just want the server to generate the best possible page and then it becomes interactive when the client loads it, don't do this. Just call the component. Maybe wrap it in a suspense if you have some async stuff, because now you'll get the right HTML. And then if you're wondering what hydration is when the JavaScript code runs, figures out which components match its JavaScript code so it can catch up and do the right thing going forward. Anyways.
You kind of think of this as this is a program for two computers, and this is the first step. And this is how it says, this is what you're going to do next. And this is, this is the code, and this is the data that this code needs without going back to the server so that it's available immediately.
That was a really good underrated point here as well. Right now, if a component needs to get data from the server, it's effectively impossible for the client to say what data it needs. It can fetch data and hope it comes back in a certain format. But as I showed in my code there was no ability to have a component that describes what it needs. And in this client code, I said that this component needs these three things. In the earlier cat generator, I said this component needs, in this case, props children, but it might need cat name. The component itself can specify what it needs, or if it's a server component, it can just fetch it on the server side itself. The idea of what I call effectively prayer, which is what I've seen in a lot of code bases doing things on client side, is they have a giant Redux store fetching from 15 different places, and they hope all the data will be there by the time the component needs it, but it might not be. What if the component specified that it needs this data, and then you have to pass it that data or you can't render it? If I just don't have C yet, and I comment that out, I get a type error because I'm missing one of the properties that it needs. You're now guaranteeing that the client or the component at any level has the things it needs, either by getting them in the component or defining what they need to have passed to them. This is something nothing else really does yet. The idea of server or client-side components that define the data that they need as things that are passed to them. So cool. Anyways.
And this is really the door through which it passes, the door that allows to pass this kind of information. And so I have worked on this talk, and so that was the first phase of the process. And now I have given this talk, and this is the second phase of the process. And now the computation is complete. Thank you.
This talk is unreal. I'm really happy that I had the opportunity to riff on this, to hopefully push further and showcase all of the reasons I think this is so cool. This is really a different paradigm. And if it's not clicking for you yet, no shame. But if it is, I really hope you have the timestamp for where it clicked, because this stuff is so cool. And I want us all to understand, benefit from it, and possibly even adopt it at our companies. Server components are much harder to adopt than previous revolutions in React. Even something like compiler can kind of just be added to an existing code base. Server components can't be in the same way. So understanding them, playing with them ourselves, spinning up side projects to see what they do and how we can benefit from them is essential to really getting this new model. And in the future, I hope most React projects are built in a way that we can really take advantage of these cool new things. Let me know in the comments what you think. And until next time, peace nerds.